This shows the relative intensity in single slit diffraction for 3 values of the slit width A. The trend that you can see is that the wider the slit, the narrower the diffraction pattern. That means for an extremely narrow slit, the bright central maximum should actually become infinitely wide. However, you have to remember that these graphs are what they call normalized, so it's made to all have a relative intensity of 1 in the center. But in fact, as a slit becomes extremely thin, the total amount of light getting through becomes so small that after a while you can't see any pattern at all. Now we're going to work through a problem to demonstrate this equation. Light from a helium neon laser at 632.8 nanometers diffracts through a 0.3 millimeter wide slit. What is the width of the central maximum on a screen at a distance of 1 meter from the slit? Now we have a slit here, we'll call that width A, and then there's a screen a distance away from it that is 1 meter. So we have wavelength from our Heine laser is 632.8 nanometers. And we are interested in the size of the central maximum. So we know that that central bright spot, let's say it's about here, is bounded by the 2 dark fringes either side of it. Then you've got narrower bright spots. So really we want to find the positions of those 2 first dark fringes. And those dark fringes are the m equals plus or minus 1. So the minima are going to be located at sine of theta for the dark patches is m lambda over a, and m equals plus or minus 1, 2, etc. But we are interested in m equals plus or minus 1. So we have sine of theta equals lambda over a. Now we know lambda, it is 632.8 by 10 to the minus 9. A, we are told, is 3 by 10 to the minus 4 because it was 0.3 millimeters. So that gives us 2.11 by 10 to the minus 3. Now we're making our small angle assumptions that sine theta is about equal to tan theta, which is y over d. So that gives us y over d equals 2.11 by 10 to the minus 3. So y equals d times this sine d tan theta, but really we're making it approximately sine theta. So it is 1 meter times 2.11 by 10 to the minus 3. And that is the distance from the center line to the first minimum. So the width of the whole slit, the width of the whole central maximum equals 2 times that. So that is 4.22 by 10 to the minus 3 meters. So 4.22 millimeters.